What is an enzyme? Where can we find one? Where are they in the environment? I will answer all these questions and more in today's episode of Enzyme Environment. Here in my enzymic laboratory, we can see models of an actual enzyme. Very dangerous in the wild, but here we can get up close and personal and touch a simulation. Here we have all sorts of different enzymes of various different kinds. I will need proper safety equipment if I want to actually touch one and show you what it's like inside an enzyme. Here we have an accurate representation of what an enzyme would look like. It is a protein separated into 4 different structures. First, we have the primary structure here, amino acids. Secondly, we have the secondary structure, the pink surrounding of the protein itself. Next, we have the tertiary structure. And then we have the quaternary structure. As you can see, it is this little brown part around it representing the rest of the protein. But what does an enzyme do? That's a good question that I'll answer right now. An enzyme hunts through a process called substrate complex. It is the substrate complex model. Here we have a substrate, and here's the enzyme. How it works is the substrate enters the enzyme's active zone like so. See, it fits perfectly. And when the substrate is changed, it is now a different substrate altogether. As you can tell by its flattened nature, the whole has also now changed. It is much skinnier, meaning a different substrate can enter. Another example for how an enzyme hunts is the induced fit model. Here we have a different model of an enzyme. It is still the same enzyme, trust me. Anyways, in the induced fit model, the substrate foolishly gets lured into the enzyme's active site, wherein the enzyme will then grasp the substrate and clasp it in. The substrate then goes through a terrifying process, changing into an entirely new substrate. There, the substrate will then leave the enzyme, and the enzyme's active site has now changed shape for the new substrate shape. An enzyme affects something called the activation energy. Now what this means is that it's something we're just living regularly, it would take a long time to die. An enzyme makes it kill it faster and eat it. This is how long it would normally take to make some chocolate milk. Here it goes. It's very slow. It goes very slowly, and it's not chocolate milk yet. It will take a long time. But let's use an enzyme. Wow, that's very fast. In the wild, we will find many different types of enzymes and the prey substrates. It'll be very dangerous. These include substrates such as lipids, carbohydrates, and other things, all hunted by different enzymes for different purposes. Now we are out of the lab and in the environment to truly see what an enzyme is like in different temperatures and salinity. Let's go find some right now. Follow me and we'll go find an enzyme in this very arid area where the temperature is just right for the enzyme to be most active. Look over there, you can find one right by that tree. Follow me. There it is in the wild. The temperature is just right for the substrates to act up, making the enzyme extra active. If we look back, wow! Look at those substrates just popping in. Wow! This is truly the enzyme's most active temperature. Now follow me as we test how an enzyme reacts in the right salinity and pH level. Follow me into the acid and we'll find one now. Wow, there's one now. Look at it go. Look at those substrates whirring about right in front of it. That's crazy. Truly a spectacular sight. Here we have a live enzyme. Very wild and very dangerous. You gotta be careful. But with this one, I'm gonna show you what it means to be denatured. If an enzyme grows too hot or pH value gets too big, the hydrogen bonds holding it together will begin to tear apart, and the enzyme will tear apart. Oh my god! Look at it go! Wow, that was crazy, but we both survived. Here we have another enzyme from the wild. It's a little bit more stable though, not gonna denature as quickly. Here we have what we call a coenzyme. An enzyme and a coenzyme go together, as you might expect from the name. They assist each other in making the reaction happen that much faster. Let's see what happens when we combine the two. Whoa! Whoa! Look at all that reaction that just happened. That was crazy. Now let's talk about inhibitors. He is an enzyme. He is an inhibitor. Let me think about what I have to say first. Now we're gonna go find an enzyme in the... Fuck.
No, keep on going, keep on going.
Again. No, fuck. Now we're gonna find an enzyme in just the right salinity that makes it the most active. Follow me into the acid. There it is.
I don't know if I can jump this fence. Drew, no! You're gonna fall in there. It's gonna be the end. Go.
Sawmill me learning.